or that unwanted that software, malicious software. Now you can think it is starting with some phishing attack, like some fraudulent communication is happening. Maybe it may happen through some mail, or it may happen through some website pages. Sometimes we are, let's say abc.com, you are trying to access, but the page you are getting where you are giving your ID and password, that is not the legitimate, the actual coming from actual abc.com. Maybe that is the page coming from some hackers, some attackers, some adversaries, and they are using that page to tap your ID or password. So that way they can steal sensitive data like your login information, like your credit card information. And this type of attack, we term it as phishing attack. When this phishing communication comes through mail, it is generally intended to pass a malware or pass some worm into your system. Okay. Next, yesterday we were also talking about this man in the middle attack. In this man in the middle attack, what happens as we are talking about that some adversary is sitting in between the server and client communication. So whatever server is communicating, in ideal situation, that communication should go to the client. Otherwise, that client communication should go to the server. But in the scenario, all the communication is passing through this man in the middle attack. Okay, so in coming days we will discuss if you encrypt some data also, then also some man in the middle attack possible. But here we can take one simple solution where we are talking about DNS tunneling. Okay, first let me explain the DNS tunneling, and you can understand through this DNS tunneling method also this man in the middle attack again possible. So what do we mean by DNS tunneling? When it comes from your domain name system concept. In communication, when we try to, let's say you are accessing this google.com. Okay, google.com, basically this is a name, this is a human friendly URL that you can that you can remember easily, that you can use easily. But basically this URL is pointing to some particular IP address, some actual system, some server, from where when you are searching the some on movie name, right? That movie name related all the information is coming, it's loading from a particular server or some crawler that is controlled by that server. Okay, so that means ideally this URL is nothing but a mapping to some IP address. Okay, whatever you are writing, some .com, that is nothing but mapping to some system, some IP address, system address. Now, what is the ideal scenario? Your PC is sending some URL name, and this URL name is going to some DNS resolution part. Okay, that is, you can term it as trusted DNS server. That means it is basically resolving that, it is basically mapping your URL to some IP address. Okay. Now what will happen if this DNS server is getting compromised? That means some attacker is not planning any direct attack to your system, to your station or node. It is basically planning the attack in this central server or this DNS server. And what is the form of the attack? That is, whenever you are giving this google.com, maybe it is supposed to go to some specified IP. Rather than that, that request is going to some intended IP that was controlled, that was basically IP, that was basically a system, that is basically a server controlled by the adversary. Okay, So in that case, what will happen? You see this victim PC, it has requested some .com, some URL it has given, that we term it as DNS request. Now it is going to the DNS server. Now this DNS server is going through some firewall when some you can say some rules have been imposed that where you can go, etc. And it is passing to that public DNS. Now this either in this trusted DNS server or this public DNS, attacker has compromised that particular server. And then it was supposed to go to some other server A maybe. Now it is getting translated your request to some attacker's PC. That means here attacker is monitoring every URL that you are trying to access. Attacker is getting information, first of all, that what type of URL you are accessing. Secondly, if this type of DNS compromise, DNS name compromise can be compromised in your banking solution. That means whenever you are accessing this URL, maybe you are getting a page similar to your banking page, right? And there you are giving your ID and password. And all this information is going to this attacker PC. So this is called, this term is called the DNS tunneling. Okay. So why we can tell that this is one man in the middle attack? This attack can again be extended to some man in the middle attack. Like this victim PC, whenever it is sending any request, it is always getting passed through this attacker PC. Now, if it is very general URL communication, attacker is just redirecting that to actual. Let's say you are searching for a book, you are searching for a movie. This is a very simple request. Attacker is just passing that request to actual server. You have no idea in general that your system has been hacked or it is compromised. But what is happening when you are actually doing some banking information related access, you are trying to giving any sensitive information, at that time attacker may use that according to the requirement. So this is called the DNS tunneling, and this can easily be extended to man in the middle attack. Okay. Now, of course, it is not that whatever URL you are giving, that is getting directed to attacker, because initially it is also dependent on what is the attack point, which server has been compromised. If a certain restricted part of the DNS server has been compromised, that means limited URLs that is getting directed to this attacker PC. And by any chance, if the whole server got compromised, if there is not partial access control, so then if the whole server is got compromised, then of course all the requests that is getting directed to attacker PC. Okay. And in turn, that may be extended to some man in the middle attack. That means the victim PC is thinking it is actually communicating to the public DNS, or it is actually fetching data from the google.com. But its the real request is always getting filtered, always getting observed, snooped, passed through this attacker PC. Okay. Any doubt? Any part do you want me to repeat? Is it okay? Am I audible?
Yes, ma'am.
Okay. Okay, fine. So this is called we term to DNS tunneling, and then in other way also, in your gateway also, this attacker, it is dependent. This man in the middle attack, that's why I'm telling it is a very general attack. And when we will discuss about CAN, we will discuss about automotive, other V2V communication. There we will see this, how this, the name is same, but how they can be plan this type of attack in different way. In this man in the middle can sit in your gateway also. It can compromise the gateway, not only the DNS. So that way it can, in the CAN node, it can compromise one of your CAN node station. Let's consider your we will discuss when we discuss about the automotive, that smart automotive is having multiple ECUs, right, connected. So all the all the smaller nodes, like for your maybe brakes, for your window, for your steering, everything is basically controlled by this ECU nodes. Now these ECU nodes in CAN scenario, they are connected like this to a central bus. And here also we will discuss there in detail, that if one node is getting compromised, from there attacker can actually access what is going on in the bus, and sometimes it has the power to manipulate or modify that. So this is the concept of, so man in the middle, this is just a term, and we will use that in various contexts. It will be different where this attack has been planned. It is different application by application. Okay. Then it is called one simple thing, that when the attack has been planned, that is zero-day exploit. Sometimes it happens, you will see that some network vulnerabilities, it is announced. Okay, when some protocol comes into picture, after few days, if some vulnerability is detected, companies, they generally announce that, and they tell in that way, okay, some patch will be given, some patch will be delivered. This time between the vulnerability introduced and the patch has been released, this part we term it as vulnerable window. And in some cases, attackers also plan their attack. This is termed as zero-day exploit or zero-day attack within this window, when these vulnerabilities are known, and according to that known vulnerabilities, attacker, they plan some attack. Okay. Now this is next one. This is, we term it as SQL injection. Okay. What do we mean by SQL injection? Okay, the structured query language. I hope all of you some way or other somehow use this SQL query, you know, right? Is there anyone who never used, or you have no idea about this SQL query? Anyone? Okay. So at least you have some knowledge about how this SQL query processing takes place. Like, you have one database, and any client can ask, if want to get some information about some particular data field, particular column, particular row, then this SQL query can be triggered. Like, it can for a particular user, it can check how many users are getting some salary greater than some 1 lakh or 2 lakh or something like that. So it can plan some conditional query, and that conditional query can fetch the information for that attacker. Now, how hackers, they can also use this information, or they can also fetch that information. It is dependent on how you are designing this database. Okay, or you are designing, you are querying, you are restricting your types of queries. Okay, and there are some form of queries that we can consider as malicious SQL queries. One example is given here. Select star from users. If the star operation can be is allowed, the star operation from users, if it will give the information about the all row and all column of your database. So that means whenever this database, because we have seen the databases are important whenever we are storing the huge data generated from IoT. So there, when during the course of database generation, these type of SQL queries are allowed, it is obvious that hackers may, if they get any successful information, if they get any information, valid information after executing these type of queries, this is a huge information loss. So what is the solution? What we generally do, based on for the types of queries that we can actually allow to be executed by different types of users of those database, we put some access control. And that access control is mapped with your login. Like you have some login with some power of query execution. So from that login, the access control is, your login is mapped with some access control. And that access control will define how much, what type of queries you can actually process. So in database design also, if this part should be included and should be included from the sketch of the database design. Otherwise, this can be a point of attack where if this type of malicious, this type of query processing is allowed by anybody, then hackers can also take the advantage of that, and it can plan that type of query and it can extract data. So this type of query, we term it as SQL query injection. Okay. Next, we will talk about some injection attack. Okay. Now, of course, SQL, there are two things. This SQL injection, one part of injection is that you are injecting this type of malicious queries to your vulnerable database. Another type of injection attack we will discuss that is a bit involved, and we have to understand for that a basic about how our queries or how our instructions get processed in the system. Okay. So what we understand by injection attack? In an injection attack, an attacker supplies untrusted input to a program. This input gets processed by an interpreter as part of the command or query. Okay. In turn, this alters the execution of that program. Injections are all amongst the oldest and most dangerous attacks aimed at web applications. Now we will see one by one. We will answer one by one. First of all, what may be the limitation of your application so that attacker is successful to supply any untrusted input to a program? How it is possible? First, we will see that. Next is that why it will be considered to be processed as part of your command or query. That means attacker is passing that as a part of your command or your query. Okay. And then how it is related to execution, altering the execution of the program, or how it is related to execution of that program, of any program. And then if we understand these three steps, we will clearly understand that how this will lead to some basic attack. Okay. So for that, okay. This is in general, we will discuss about how our instruction processing takes place. Okay, maybe most of you know this part. Just a quick recap that all of you, I believe you have written some C code, right? And there you have written these type of high level language statement, right? Like this, maybe you have used different types of operators like multiplication, like addition, any type of instructions you have written. You have written A is equal to B plus C. Then C is equal to C into D and so on. So that means your system, when you are executing this code, your system will know that you have to execute this instruction first, and then system will know that it will execute this instruction first. The next, how it is known? It is known by this instruction. The code related these instruction is stored in some memory part. We term that is instruction memory or instruction cache memory. Okay. So from there, instructions are fetched one by one and they are executed through using your underlying ALU, arithmetic logic unit. So in this case, based on the type of, there are different types of representations of instruction. We are just considering the simple register type of instruction, and there are other types of instructions. I'm not going into the in detail now. It is just to understand that how this attack can be formed, or what is the way this, what is the meaning of these 3 points we have discussed. Okay. So first, when this is a representation of your, let's say, this instruction. Okay. So this part tells the type of the instruction, what you are going to do, addition, subtraction, multiplication. So this is the type of the instruction. Now this part is the register. Maybe you are these are the two source registers. You can think that means this is one is S1 and one is S2. Okay. So these two registers, these two bit locations, they are specifying from where the input will take the data, fetch the data. Then it is the destination register, that is register 8. Okay. And then these are some unused part that is reserved for some future instructions, other type of instructions. Okay. And this is the addition opcode. Sorry, this is a register type of instruction, and this is the addition opcode. That means it is opcode signifying that what type of instruction you are going to actually execute. Okay. This is ALU type of instruction. If it is having some other code, it may be memory type of instruction, memory load, store, etc. Okay. So basic idea is that these are some, whatever you are writing in this high level, it is getting mapped to some 10. Binary level 10s, and these 10s, it is getting stored in this instruction memory. Okay. Now, during the course of instruction, what the this is a program counter. We term it as PC. This is program counter. This is just a register, nothing else. It is fetching the instructions one by one, checking the fields, checking the maybe the source locations from where the values should be fetched. It is fetching the values. It is giving that to the ALU, arithmetic logic unit. And also it is giving the information about the opcode, what to do. If it is addition, according to that, ALU will do that addition and the result will be stored in that destination register file. So this is how instruction execution takes place. Now you have some subsequent instructions. One by one, PC will fetch these instructions according to that instruction address, and then it will execute. Okay. That means after this instruction, some 10 address, the next instruction address is there somewhere. And if this next instruction we can change, that means your system, your flow of execution will change. Your system will execute some other instruction. Maybe if you replace the these 10 values with the instruction address of maybe this for this instruction, then this XOR instruction will get executed after add and not this subtraction instruction, right? So that means it is arranged in instruction memory. Now what happens to this buffer overflow attack, where we typically attack and where is the change? So up to this part, is it clear? What is the instruction flow or how the instruction execution takes place? Is there any doubt for this part? Anyone? Okay. Now what happens in this buffer overflow part? In this buffer overflow, if you think in this way, you are writing these type of nested functions, right? Nested function means this is your main function. See, this is your main function, and within this main function, you are calling this function void area. That means when we do this type of program execution, some memory, that is we term it as program stack, that is allocated for each and every program, and that program stack stores the details of your program in execution. And as and when you are calling one function, that for that function some space gets allocated to that stack. Now take this example, like here we are considering this main memory. So all this main memory local variables are getting stored. So this is the memory location. This is area where this main memory related variables are getting stored. Okay. After that, there is a call for this function, this area23, right? Now, for this, there are two things. The first thing is that you have to store the information about this. What about the variables? What is inside area? Here, this is just only one simple line, but there may be more variables. There in complex scenario, in actual scenario, there may be more variables, more instructions. Everything you have to store in the next level buffer. That means you are having some area here, okay, where it is storing this A's local variable. That means from main to your calling area, maybe that is A. And inside A, you have one buffer call, which is, for that also you have specified some space. Now, can you give an example where we use this type of buffer, or what is a practical example where this type of buffer can be used or required? Anyone? Hello? Anyone wants to try?
Could you repeat the question?
I'm asking that here. Wait, just a second. You can see here, right? This is, we are in void main, you have written one function area, right? In that area, I have specified what int buffer. So we have specified some array, right? Or any buffer we take into account. Can you give an example in which case we assign some buffer, or a buffer means what? Array, buffer, or that means some extra memory we are assigning. In which case we do that? Any other example other than array we do that?
For the reading the data from sockets or doing network communication, stuff like that requires buffers all the time.
Yes. Not only, yeah, you're correct. For network value reading, etc. Take a simple example. Whenever you are writing scanf, you are taking some user input. Maybe it is inside one array, or you are using the getS, putS, this getS value. GetS means you are expecting whenever you are writing this. You all have used the string inputs, right? Have you done?
Yes, ma'am, definitely.
Yeah. So these are very basic examples when you are expecting, when your program is expecting some input, any input from the user. Go back to this SQL. Why I am relating this to SQL injection? Go back to your SQL this database, or you are logging to any website. The first page, it is you have to give your username and password. Now you think when you are designing these type of application, basically what in the designer end, what you are using, this type of getS type of function. In that getS type of function, it is expecting some string from the user. It is expecting the string, the password, and that password may be stored in that string or this buffer, integer character buffer, whatever it may be, character array maybe. Basically, it is expecting some input from the user. So these are very simple examples. Whenever you are where you are expecting some input from the user, your application is expecting some input from the user, you have to be careful. Okay, why? Because what happens, you see, this is the buffer. For this buffer is expecting some input from the user. Okay. Now you have specified here this in buffer 10. That means for this buffer you have allocated one array where each location of this array will hold some int type of value. Now how many bits or how many bytes are specified, designated for this int character type, that is fixed, right? That means if let's say you have developed one application like this and you ask me to input the data, input the password. Now what adversaries can do, they can, if it is this check is not there, right, like in initial compilers, especially why I am mentioning this getS type of functions, there was no check on the size of the string you can actually input. So that was a noted vulnerability. So what is the problem? Now your user, adversary, instead of their own password, they will give a huge size string. Okay. And what is the drawback? See here, you have specified this program stack, and this program stack has allocated some amount of memory for this function, and in that function you have this buffer location. For that buffer location, some specific amount of memory has been already allocated. But the application function you are using, that function does not have any check what may be the maximum size of this buffer, what may be the maximum size of this string that is coming as an input. So what is the drawback? When any adversary is giving a huge string, then and you are processing first level, the password, your application is checking whether there is a match with that password or not. At that level, this buffer is growing in size because your string size is really huge. It is really big. You have not set any condition that, okay, your password cannot be more than that, this amount of maybe 10 characters, maybe 12 characters, whatever it may be. So there was no check. Now this buffer has grown, but the buffer size was initially specified by the hardware and it was fixed, but now it has going out of range, and these values, it is overlapping. You can see there, it is changing some bits of this return address field. Now, initially, main function, this main function, initially there was a plan that main function will complete the execution of this function A, then it will come back to this return address. And from this return address, whatever instruction, return address means some address in this instruction memory, it will come back here. This is the return address. It was pointing to that address. But now a few bits of that return address got corrupted because your string is now going larger, the input string coming from the user. That may be the adversary. It has given input as a huge string and it has overwritten some of the places here. See, some of the places had got overlapped. Some of the bits got overlapped. Now there are two possibilities. Now the problem you understand, right? That main program, now it is after completion of this function in A, it is trying to return to a particular address and some bits of that return address has got modified by the inputs of the buffer, came into the buffer. So now the return address, there are two possibilities. That is, this return address may be invalid. Like you have 10101100, maybe 01. Maybe it was your initial return address. Now after this buffer overflow, maybe 2-3 bits, maybe 3 bits got modified. And now 10110011. Maybe this is your now value of your buffer. Okay. It may happen there is no valid address in your instruction cache memory. That means this is not a valid address at all. Your program will get some segmentation fault. That there is nothing to do. There is nothing that this program is failing to execute properly. This is one possibility. Okay, up to this part, is it clear or should I repeat? Is it clear to all of you?
Ma'am, I have a doubt.
Yes, tell me.
Ma'am, the B array, will it grow downward or towards the return address of?
It will grow towards the return address. Now, upward, downward is very relative. Okay, because this is this is the active space at that time. Okay, this is the active space, so it will go towards the return address. Fine.
Okay, ma'am.
Okay, yeah. Then what else? Anyone else? So for everyone, it is clear, right? How buffer overflow is taking place. Okay. So if that is the case, now this return address, you understood that it is getting modified. So what type of fault you will get during your execution? Have you observed any memory related fault?
Segmentation fault might take place because of pointing to an invalid location for the program's memory.
Yes, correct. So this is in general, if we are getting segmentation fault, then also we are safe. Why I'm telling we are safe? In general, what is the target of buffer overflow? Not only to make the segmentation fault. Why? If in parallel there was one malware in your system, that's why I was telling, then that the attacks are not separate. In general, when adversaries they club attacks together. So what happens when if you are getting segmentation fault, okay, you can understand nothing is working in your system. At least you are getting a clue. But what adversary on the reverse, what adversary can do, or it has previously implanted any malware in your system. So that malware is doing nothing, but it is monitoring the growth or the memory usage of your system. So that means it knows the memory range, it knows the memory values, and in the instruction memory, it has placed some unwanted code somewhere. That is the malicious code somewhere. Okay. Now this buffer is growing in such a way that it is modifying the return address, and it is modifying not to a invalid address, but it is replacing all the bits of this return address in such a way that this return address location is pointing to a location where this malicious code is residing. Got it? Clear? That means initially what was the case? Initially some bits were getting, I mean this is your buffer. This buffer is growing now, and this here is your return address. This is, think about this way, this is your return address, and this return address is getting overwritten partially. If this is the case, now this return address becomes invalid and you are getting some segmentation fault. But if the buffer grows bigger and it covers the return address in such a way that it is basically replacing, it has given input, the malicious input, it has done this injection. That's why this attack term says injection attack. Someone was asking, it will go this direction or this direction. You can think about in this of representation. It is basically the memory part is the next level bits are getting corrupted, and in the next level the return address is residing. Okay, that is the arrangement of your any program stack. So that way now it is this part, this return address is pointing to some memory location where you are having this malicious code. That means now your program counter, instead of pointing to any valid location, it is pointing to this malicious code and it is executing that malicious code. If that malicious code is executed, it can do anything. Now it can, in simpler way, it can now spawn several unwanted codes, and it can lead to several unwanted data it can generate, and it can lead to some denial of service attack. So that way, what I was telling, nothing is disconnected. No, there is no separate attack. Basically, one part, it can always start from a phishing. Then a malware can be introduced in the system. It may happen that malware, it is just this malicious code, it is just modifying, encrypting your data, encrypting your files, etc. That means some encryption code is running. That encryption code is running means somehow your adversary has got the control of your program counter, that in such a way that program counter will now, I mean, execute the instruction from a malicious, I mean, it will return, it will point to some return address, it will point to some return address or address in the instruction memory where some malicious code is residing. Now this malicious code is your some encryption code. Now this encryption code, when it is executing, it will take the input of all your files, it will encrypt and it will keep it encrypted form. Now once that is done, this notification will be sent to the adversary and you will receive a mail that to get the decryption key, you have to give this amount of money. Okay, that may be the form of ransomware. It may be the form of spyware. If this that we discussed yesterday, what happened to that in that Iran's nuclear plant, that server system, where the spyware, we are terming that a spyware if this malicious code is just observing the situation of your, I mean, what is going on, what control input, control output is coming in, going out in your system. Okay, in that way, that is basically spying inside the system, getting information about your control inputs, outputs, and it is planning for some next level attack. So we are terming that as a spyware. If it is just, it is just spawning some extra code, illegitimate code, or it's just wasting your resources by some invalid operations, then we are terming that as denial of service attack. So that way you can see that these terms are different. But once that's why injection attack, this is one of the very important. Actually, you will do one hands-on on this buffer overflow attack. Okay, maybe in the next week. Okay, in some virtual system, we will give the link, so how to do it, etc. So there will be one hands-on, because if this part of this system control is taken, an adversary is capable of controlling that what code you can actually, your system is actually executing, then next parts are easy. Next thing, what to do with that code, that is easy to control. So that way, this buffer overflow attack, this is a very this type of injection attack. This can be plotted against SQL injection also. Like when for a SQL some database or website injection also, we term it as website injection, when this type of malicious codes are injected in website servers, and the same type of attacks are planned basically. So this is injection attack. It itself is it's a sort of mother attack, which may lead to different types of other attacks with which objective is different, but basic idea of the underlying attack, basic technique of the underlying attack is very much same. Okay, so is it clear now, this part? This part, is it clear? Anyone, any doubt? If I now, so can anyone explain me about this buffer overflow attack? Anyone? Hello, am I audible?
Yes, ma'am.
Anyone wants to try? Can you explain that what is going on in this buffer overflow attack?
Yes, ma'am. There is a buffer. There is a limit of the buffer size, but when user is giving the input, there is no checking that how much input the user can give. So if user puts
again, yes, here if there is a limit in the implementation point of view, then this buffer overflow attack can never happen. Okay, so it is the implementation's law that when we are introducing this type of buffer, or in this type of we are expecting some input string, and we are not, from the implementation point of view, we are not limiting that what may be the input size, then this buffer overflow can happen. Okay, next.
Yes, ma'am. When we input a very large, then the attacker, the adversary might input a very large string, so it might overflow that buffer and it might corrupt some of the bits of the return address. Or then that if the return address is modified in such a way that it might point to some malicious link, malicious code link, that is program counter is pointing to some malicious code link, then malicious code may run and it might corrupt or encrypt the files, for example.
Okay.
But ma'am, we will once we got that idea. I think I got that idea, but exactly how the bits are getting modified and exactly it's getting matched with that particular address, that thing is not clear, ma'am.
Yes, that part I think once we will do hands-on on this, I think it will be more clear to all of you. But as of now, that initially I think segmentation fault type of attack, it is easier. Like if adversary gives any random input and there is no check on that length, then segmentation fault can be easily planned, right? But for actual injection, for that injection, the previous steps to be taken, like there will be some worm or there will be some malware, some software that is in the system and that is having the complete knowledge of your instruction memory. There are two things, that software is placing some malicious code in some part of your instruction memory. This part is getting corrupted by the adversary. And the number two, what is the address of this location that is this malicious software is having knowledge of these part of the code. Sorry, I have this address of this part of the instruction memory. So whenever it is giving input to this password field or this user ID, whatever field may be, it is basically calculating that when after some buffer size, this part should be overwritten in such a way that it will specifically hold the address of this part. Okay. So in that way, when PC will point to this address, of course, it will fetch the values from this address, what to do, like the instruction opcode, instruction type, everything will be fetched from this part. Okay. So I think that exact match, etc., that when we will do hands-on, it will be better for all of you. So any other question? Anything else?
Ma'am, how would the adversary get knowledge of the memory structure of the program that is currently executing?
So that's what I'm telling. It is not just, you are not starting from this part. Okay. This buffer overflow is not an isolated attack. That is, adversary has already spawned some malware in your system. Okay, there is one application software that is working as a spyware, and that spyware is basically taking the information about this instruction cache. Got it? About this instruction memory, and it is planting some malicious code. That is the first thing. That is that you have installed some like software. That software is installing some, installation means what? Installing some application means what? Basically, you are planning to execute some code according to that application. That means somewhere in your memory, you are storing that instruction related information. Is it clear? Is it correct?
Yes, ma'am, but that is going to be a separate application program, right? So, and
Yes,
two application programs are going to have, by the means of virtualization, and they are going to have different segments of memory allocated to the both.
no,
So,
what I am telling, it is not starting with this buffer overflow. Okay, these are
yes,
two
yes, ma'am, I
club
understand.
attack. The
Yes.
first step was there, already some malware was there in your system to have this, like the spying. Like the spyware example we were discussing yesterday. Initially, that malware is not doing anything. It is just observing these instruction memory details and the memory input output, like it was shown. That was a practical attack. It was observing the control input output. So from there it is getting the details of your instruction memory, and through that application you have already installed that application code, some part of the application code. Later on, that application code is getting mapped, or that location is just getting used. So your adversary, through that malware, through that spyware to be specific, is having the application or having the information where your malicious code is, residing in the instruction cache. Otherwise, it cannot update this buffer in that way.
Okay,
Right.
okay.
Otherwise,
Yes.
it will be a segmentation fault. It may happen that it is just uploading the buffer just with some random value. That is possible, right? Up to that part is clear, right?
Yes, ma'am, absolutely.
The segmentation fault part is quite easy, because that time if there is no check, this buffer will grow to the return pointer with some garbage value, and this garbage value will lead to segmentation fault. But to make it exact attack, to get the control of the system, this type of malicious code, previous code is required. We will discuss this type of how control can, okay, we will come next with this ARP spoofing. Okay, there you will see how this type of this malicious code can enter in a very comparatively simpler way. And then this type of buffer overflow can be planned. That may lead to, there are three things. All buffer overflow is not injection. This buffer overflow can lead to your denial of service, where all your program is just leading to some segmentation fault. That's all. Your program, the execution, the proper it is not performing properly. But if it is, buffer overflow can be clubbed with other type of attacks that may lead to injection. Okay. Now,
okay,
yeah. Now come to the ARP spoofing. That is another technique. Okay. So in ARP spoofing means the full form is address resolution protocol spoofing. Okay. When it is possible, it is in general, it is possible when it is a ARP protocol is basically in network layer protocol. Okay, network layer protocol. In networking, what we do. Okay, do you all know about this OSI layer, or this general idea about communication, the basic idea? Is there anyone who is not having that? Do you understand what do you mean by network layer, all of you? Everyone? Yes, no, anybody know? Then can anyone tell what we mean by address resolution protocol? Hello? You please respond, then I will understand from where I should start. Otherwise, if I just tell the terms, then you will not understand anything.
Ma'am, IP, that is IP address is translated to physical address or MAC address.
So you're from anyone from the electrical background? Anyone is there? Okay. Can anyone tell other than Aditi? Okay. So let me explain. So in general networking, when we go for maybe a system, maybe this is, you can think that these are, this system A is trying to connect to this system B. Okay. Now this system B is a part of another network. So when system A is sending some data to system B, so what is the first thing? It has to identify its network. Like, I'm assuming that you have all the basic concept of network, and this data should go to the some network nodes, network gateway maybe, and in that network, system A should identify among this within that network, what is the host ID of this system B. Now this system B is associated with two types of ID. One is NAT ID to identify the network, and this is the particular host ID, that is the physical address we can tell. So that means when the system A is sending some data to another system, system B residing inside another network, the first thing to identify what is the is the network, and the second thing is that what is the physical ID of that network, or the host ID of that network. So what is the process? What in general address resolution protocol, what do you do? Anytime a host or router is sending a packet, data packet, we term that as IP datagram, or you can remember that as a packet, no problem. It is sending that, it is basically sending one, the host or the router sends one ERP query packet. What is ERP query packet? This ERP query packet that includes physical and IP address of the sender and the IP address of the receiver. Okay. And from these IP address, as a response of these query, what the sender or host is expecting, it is expecting to know the physical address of the receiver. Okay. So that is the basic idea of the address resolution protocol. So maybe in this network, there are multiple nodes. These are the multiple nodes, and one ERP request, ERP query, ERP queue. You can tell it is flooded in the network. Okay. So this ERP query packet, these are the stations A, B, C, D, or the nodes as associated with that network. All are receiving this ERP query packet. Okay. And this ERP query packet having one IP address of the receiver. Okay. So all the nodes are receiving this request packet, but all of them are not responding. Okay. Only the intended recipient who is getting a match with this IP request, that means whose IP value is matching with the IP receiver field of this packet, that node only sending one response packet that yes, my IP is matching, now send me the actual data. Okay, that means this is a general comparison of IP, or whatever IP value, receiver IP value given in this request or the query packet, and there is a comparison of its own IP. Every station is comparing with that IP field and sending a yes, I am having that same IP, now send me the packet, my address is matching. So this is the basic concept of address resolution protocol. That means from the given IP address, host or router is getting the idea of what is the actual host, where can I send this packet. Okay. Now see, there are two problems. First problem is, if some node is already compromised among this in this network. So what it will do, it will basically accept this address, this ARP request, query packet, and it will send a false response that yes, my query, my IP is matching with that packet. In an in-depth attack, what happens? Let's say this IP request, it is matching the IP of, let's say, B. Okay. Now this B is not compromised, but this C is one adversary is controlling this node C. Now here also this adversary can plan one man in the middle attack, and it can connect, it can communicate, it can take the response of this B, modify the IP value of host value, the physical address value of in the packet, and it can send that packet back to the IP packet back to the router or the host at the response. Okay. So in both the cases, the final response, what the router is receiving, it is basically the the IP of the station, of the physical address, the host address of the station, which is controlled by the adversary. So this is one, flaw of the network design or limitation of this protocol, that here the ARP, this query packet sending process is broadcasted, and all the informations is all the stations are getting the information about the IP. Which IP is, what is the actual destination IP? This is the first thing. Next thing is that maybe initially this change is not made. Initially, it may happen whenever this address, this query packet is coming, the adversary is doing nothing, but it is just observing what is going on. That means for a particular IP request, what type of response is going on. So it is basically observing this IP and the response, this mapping. And from there, it is getting the idea, information about the whole network, that for what is the IP and what is the host ID map, host IP map. And then in a later case, it is using that mapping information for some future attack. Okay. So this part, it is basically spoofing the IP, modifying the information in the response packet, and taking the information, taking the packets to a particular destination. Okay. So in that case, the source is thinking that, okay, it is sending to the information to maybe some IP address with some IP address. But in actual case, that information, that packet, that IP datagram is going to some other node where the adversary is residing, or the adversary has taken control. So this type of attack, we term it as address spoofing, ERP spoofing. So you can see here, this is the ERP, this is the attacker. Okay. Initially, this attacker is having, this is having some MAC, this is having some IP, some mapping. Okay. Now, this is initial the communication. Now the attacker is taking the in-between ARP response, and it is replacing that with its own MAC value. Now see, it is replacing that with its own MAC value to the router. Now whatever communication in next level is going on, that is going on from router to this attacker. It is not going to this actual host which was having this MAC value B. So this is called the ERP spoofing, where this attacker is basically falsely giving the identity of some other node. Okay, so that is the step. The attacker replaces the MAC address of the messages that contain the IP address of the network resource with its machine's MAC address. The victim's machine that received the spoofed ERP replies cannot distinguish them from the legitimate ones. Moreover, the ERP tables usually use the result of the last ERP reply only. That means when this router is receiving multiple responses, multiple replies with respect to one ERP request, it always takes the last information. And there is a high chance that the attacker has at that time spoofed the ERP information and sending the last reply. So in that way, all the communication it will go in between router and the attacker. Okay. Is it clear? Now the attacker takes the role of the man in the middle. So this is again another form of the man in the middle, which is basically coming in between a legitimate node and the router, and router and the legitimate node. Okay, is it clear, this part? Yes or no? Any response? Any part should I repeat?
Ma'am, what is MAC address exactly?
MAC address is the physical address of your system. Okay, and IP address is a virtual address when you are connecting your system to their network and some IP address is given to you. And MAC address is a physical address. So final data communication or packet delivery or packet communication takes place. Here we term it as that packet as IP datagram as to the actual physical address. So that is important. And there is always a mapping. So that mapping is between these IPs for a particular what IP is given to which system. So that is a mapping between the IP and MAC. Clear?
Okay, ma'am.
Any other question? Is this attack clear? What is going on?
Yes, ma'am.
Okay. So this is this we term it as ERP spoofing. So just a quick recap from the start what we have discussed. We started with a simple malware. Okay, malware means just clicking a link, some code is coming into your system, and then gradually we are checking what changes may happen with that code. Okay. Then we discuss about this denial of service attack, where this malicious code can spawn huge amount of irrelevant data, irrelevant processing requirement, and that may lead to denial of service attack, where your legitimate processes, they will starve for that actual resources or the bandwidth, and then they will not complete, they will miss the deadline. So that is the concept of denial of service attack. Then comes the phishing attack, where some fraudulent communication is coming. Okay, this is basically fraudulent communication, fraudulent data input is coming. This generally happens in CPS scenario, we will see next day. If there is lack of authentication, like one node is receiving data, but that there is no authentication technique, that no authentication check to be specific, that from where that data is coming. I am telling you I am node A, so where is the guarantee that what I am telling it is correct? So for that, these phishing attacks are possible. We will discuss this in CAN to be specific, that how this phishing attack to be prevented and what are the overhead to prevent that security solution. Okay. Next comes the man in the middle attack. This man in the middle, it is a very generic term, and in different scenarios, maybe gateway control, maybe ARP spoofing in different scenarios. This is a concept basically. This is not the name of a particular attack. This is a concept where this can be understood, like in between gateway, in between ARPA spoofing part, in between SQL injection extension, then DNS handling, everywhere these concepts can come into picture. Okay. Then we talked about zero-day exploit, where we talked about some days, few days, free days, where your network is vulnerable, and adversaries are having the knowledge of that, and they're using that knowledge to exploit your system. Okay. Then comes the DNS handling, when you are accessing a particular site and that site is getting redirected. I mean that site with your DNS request resolver, if that server is compromised, then your request is going to some attacker PC, some attacker server, where your information may be stored or processed in future, may be used in future in some adversarial way. Okay. Next comes the SQL injection. When we are talking about SQL injection, there are two issues. One is what type of query you are using. This comes from the limitation of access control in the database. Like types of your query we are using, that may leak huge amount of information about the database itself to the hacker, to the adversary. The second type of injection, or the most involved type of injection attack we have talked about, it is the when some unwanted code is getting the chance of execution in your system, and that is possible if this buffer overflow attack is possible when in your system application is demanding some input from users, and it is loading some buffer, maybe in form of string, maybe in form of characters, maybe in form of integers. Generally all is getting mapped to some binary values, and those binary values will, if there is no check, it can replace, it can overwrite some of the parts of the return address, and that way this with this address value modification, some segmentation fault can be planned, which may lead to some denial of service attack, or it may lead to some a total override of this return address to some malicious address location, where the adversary can take the hold of the system. Some malicious code can come into can start executing, and this is the basic concept of injection attack, where a vulnerable code is injected in your system. Now it comes to the ERP spoofing part. In the ERP spoofing part, it is mostly network protocol related vulnerability. That is a limitation of the how this is a known address resolution protocol, is a very standard technique, but it is the limitation, security limitation of this protocol, where there is no check when a source is sending a request through this ERP packet, address resolution query packet, and it is for a particular IP, it is requesting for the actual MAC ID or actual physical ID of the node. It is requesting for this IP to physical address mapping to all the nodes. But the problem here is this, according to the standard protocol, the initial level protocol, there is no check that if the nodes are, whatever information the nodes are giving back, whatever response the nodes are giving back, next level protocol is taking place. There is no check whether all the nodes, they are actually giving the correct information, or there is no check what will happen if any of the node is getting compromised. If and then the whole network, the whole communication is open to that adversarial node. Okay, so these are the typical types of attacks, and we will see the different why I have discussed these type of another one we will discuss relay attack. I will come into that. This is a very specific attack. In general, these types of attacks in different form we will see in different applications. We will see in CAN, we will see in medical domain also that some form of these types of attacks we will see. And in general, we will discuss what may be the solutions and what is the most specifically, typically, what is the overhead to apply those solutions in CPS scenario. Okay. Last one attack that we will discuss, that is the relay attack. This is very typical attack, and this is mostly, I mean, observed. I have already given this is a reference you can check for this attack. So it is basically attacks against the smart cars. Okay. Now, mostly you all have seen nowadays the cars are relying on the smart cars. They are basically having keyless entry, right? If you have the keys in your pocket, then you can just open the car door and you can enter. That means there is some signal communication. What I see, some typical signal communication that the key, if it is within a typical limit, typical range, like your card is here and your key is maybe here within a typical range, this signal communication is possible. This communication between card and key is possible, and based on the card's request, some input is coming from the key, and then this communication will take place. And anyone can open the card if the key is within a particular distance. Now, how it happens? It is between this card to key communication. When the generally, typically, smart cards, they send some information, periodically probe some channel, general channel, with some small messages, and based on that messages, these keys, if they are in range, they send some acknowledgement. There are two types. If there is no dedicated channel between the card and the key, that is a highest possibility. Then initially there is some wake up signal, and then card some response comes in the form of acknowledgement. Then this a challenge comes for the car from the card ID. There is a key pair first. These are all basically basically this key and the card, they're connected with some RFID tags. Okay, and some challenge is coming from the card ID. And if the card ID is correct, if it is matching with the key will send some response. Okay, and the card will check based on the previously selected key pairs between, like, this card is sending some information with some challenge. Based on that the key is sending the answer. If this answer is matching with the question, the key pair is established, key pair is satisfied, then card is okay, the card is opening. The same thing is here, only this card and key is having a dedicated channel. That is not very usual case. Okay. Now, what relay attack says, it is basically only a key with a previously paired RFID tag would be authorized to start the engine. Okay. When the key detects the signal on the channel, it wakes up the microcontroller, demodulates the signal and interprets it. After computing a response to the challenge, the key replies to the channel, considering it is explaining this part that you have a particular channel established. If not, this is the part. The response is received and verified by the card. In the case of valid response, the card unlocks the door. So that is the typical idea of how these smart keys, they interact with the smart cards. Okay. Now, what is the concept of relay attack, or how it is related in this case? In a basic relay attack, messages are relayed from one location to another in order to make one entity appear closer to the other. That means, with all this assumption, your card is expecting, when this card is receiving any response from the key, it is assuming, okay, the key is within a particular close proximity. That means key holder, the owner is the card, actually sending the response. Okay, and it is opening the door. That is the basic general idea. But with this relay attack, that means there is some modifications we can make, that the messages, these key, maybe it is not in the close proximity. So, but it is in some distant place. That means you are having your key in your pocket, but from there the signal is the car signal. When the car is sending the beacons, it is getting amplified, it is getting passed through some antenna, and it is coming to the key, and that's the key, maybe it is placed in some distant part. The same way, the information, the challenge, the response, the key response from the answer to this challenge is getting passed again in the similar way through some amplifiers, through some filtering technique. It is get back to the card, and in spite of the fact that you are having your key in the you're having your car key in your pocket, but just by modulating those signals, amplifying those signals, and channelizing them to this car responses, someone else can actually open the car. Okay, so this is one typical attack. It is a very interesting attack against recent smart cars. So you can go through this paper and you can check this out, how this is how the keyless entries can be hacked through the concept of relay attack, where you are doing nothing, you are using some amplification and filtering of the signals, and in that way you are modulating the signals, you are sending it the key, you are extracting the key response, and that response you are giving the same way you are giving back to the card. And that way, in spite of the fact the actual owner or the key is not in the proximity, it is possible to open the card. Okay, this is a typical attack. That's why I kept it at the end, because this is a typical attack against the smart cards. Or in similar scenario, okay, that is not exactly in the CPS nodes where they are connected through somewhere, so they are connected through some shared medium also. But this is a typical attack where your signals can be modulated, that can be amplified, and then this relay attack can can get, with that relay attack, adversary can take the hold of your this type of smart devices. Okay, so you may, this is a reference, you may go, if you're interested, you may go through this part. Other than that, mostly whatever we will be discussing after this, we will be taking different applications, and we will be revisiting these type of attacks, whatever we have discussed today, and we will see what may be the solutions, or typically what type of attacks, how we can classify them formally, and what type of solutions we can propose for those particular applications. Okay. Is there any question? Anything? Any part you want me to repeat? Nothing? Okay.
Hello, ma'am.
Yes. Yeah.
Can you repeat the relay attack again?
Relay part. Okay. So in relay part, what is happening? Like card is and key is the keyless entry. Like you are having you are directly not using the key, right? Maybe most of you have seen that. You are having your key in your pocket, and there is some signal exchange, okay, between your card and a key. Initially, that is the card is constantly probing. Okay, if this the key is within the proximity, and if there is a need to open the open the door or something like that. So that is first the card sends this wake up signal, and the key sends the acknowledgement response that yes, I am in the proximity. Now see, if the key is not in the proximity, there will not be any key, any signal coming from this key, right? Next, if this acknowledgement is received, sometimes this acknowledgement is skipped, and then the main thing is that this card and the key, they're connected with some RFID tag. Okay, RFID tag, what they expect, you can see here that the card will send one challenge, maybe one question. Okay, question is some binary challenge, and with respect to the challenge, this key should compute the response, and that key response should be passed to this card. Okay, these are the channels. Through these channels should be delivered to the card. Now this is only possible, this challenge reception by the key or the response reception by the card. This is only possible if and only if this card and key is within some proximity, some range, maybe 10 meters, some 100 meter, within that range. That means the idea is that card owner with the key is within the range when there is when someone is trying to open the door. You see, right, when what happens when we try to open the door of this kind of smart cars, what we do, there is a button, we just press the button, we open it, and we get into the car. Idea is that our key is in the pocket. There is no need to take out the key or to use the key in any way. So that indicates that whenever you are pressing the button door handle to open it, this signal transmission, this message exchange is taking place between the car and the key. But what relay attack says, in basic relay attack, messages are relayed from one location to another in order to make one entity appear closer to the other. That means now with that relay attack, this key and this car is not in close proximity. Okay, they are not actually close. You are the car owner, you are not in the close proximity of your car. That means you are not, whoever is pressing the handle, when this probing will generate that to check whether my key is there or not, whenever you are pressing to open the door, that means some adversary is pressing your door to open it. And now what your car is doing, your car is checking the proximity of your key. But what is the attack plan? That when some adversary is pressing the door, it is the knob in the door to open it, he is not having the key. What is going on? There is going on some signal manipulation. Like your key is here, your card is here. But the signal is getting amplified. Some amplifier is there, and this amplifier is amplifying that signal, and your key is receiving that signal. And from the distance, from you may be far away, and from there, this again the amplified response coming back to the key. Sorry, coming back to the car door handle. And that way, this car is opening. Adversary is successful to open the car in spite of the fact he or she is not having the key. or the key or the car owner with the key is not in the close proximity. That means you can understand that is a possible theft. Now that's why I'm telling this is the basic concept. Now is it clear? You can actually go through, that's why I was telling you can go through this paper, okay, at least the experimental details. This is very important, not if not the whole paper, just go through the experimental details part of it. You will understand how they have made the setup and they have actually planned this type of attack on 10 types of cars. This is not something like futuristic or just a proposition. They have done that and they will tell you the range, like what may be the range of this car and the key. Then also this type of attacks are possible. Okay. Basically, this is some simple signal amplification, nothing else. But that is planned in such a nice way that this is leading to some theft, that is leading to some security issues. Okay, we will talk about this relay attack. This I have, again we will after CAN IoT the discussion, when we start our IoT discussion, we will talk about RFID tag security itself. There we will talk about this relay attack in detail in some other scenarios. But here this is related to smart car, where there is some relaying of these signals, modifying the signals, amplifying the signals, and then just it is making this attack possible. Okay. So is it clear? Have you got the basic idea?
Yes, ma'am.
Yeah. Okay. So that's all for today. I mean, if you have any other questions to ask or any other attacks you want me to explain, I will try that one. Okay. Otherwise, that's all. Thank you. You can leave if you have no more question.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Thank you, ma'am.